Okay, so this video is going to introduce you to multi-view drawing. If you think back to our previous assignment, what we did was we learned how to take an actual shape and turn it into an isometric drawing, just like this. What we want to do now is be able to take this isometric drawing and actually turn it into a multi-view drawing. All right, and so here's the key point with, or the first kind of main thing with a multi-view drawing, is it's done in 2 dimensions. When you think about this isometric over here, we can actually see all three dimensions together. We have the height that goes up and down, we have the width that goes left to right, and then we have the depth that goes front to back. With a two-dimensional drawing, we only have two of those 3 dimensions, and we'll explain those a little bit later. All right, so 4 key concepts for multi-view drawings. Regardless of how neat they are, how well they're actually drawn, this right here is actually printed out and it's really neat. You might create a multi-view drawing where you sketch it very quickly. Either way, you always follow these 4 same concepts. So the first one is that we want to make sure that our views are in the correct spot. We have 3 views. We have the front view, the top view, and the side view. This is always where the front view goes, every single time. The top view is always above it, and the right side view is always to the side of the front view. That is every single time. So whenever you create one, that's how you want to set up your drawing. You always do the front view down at the bottom corner, the top view goes above it, and the side view over to the side. Common mistakes I've seen with students is they'll draw the views in random spots. They'll put like the front view over here and the top view over here. They'll put the bottom view, which isn't even one of the 3 that we use, over in a different spot. So we always go front view, top view, and side view. Second key point I want to make sure you know is that whenever you have an isometric drawing, you want to make sure that your views on your front, top, and side view of your multi-view drawing match whatever your views are on your isometric. So think back to our previous assignment. We had our front view, which was right over here. It's always pointing in this direction. Our side view is always going this direction, and then our top is working from the top down. So whenever you create an isometric, that determines what your front, top, and side view are. When you create your multi-view drawing and you have an isometric, you already have your front, top, and side view determined. So now you just got to draw them correctly in the correct spot. If we take a look at our front view over here, you can see we have this little cutout. And you can also see on our front view over here, we have the cutout as well. We also have this sloped part, the angled part, and that is this edge right over here. So our actual shape, if we look at it, this would be our front view, okay, right over here. So you can see how it matches. Now when we go to our top view, same thing. We have this rectangle, which would be this right over here. We also have this rectangle, which is actually a sloped rectangle. And so when we draw it, we actually draw it flat, just like that. If we look at the actual top view, this is what it would look like. And now here's the thing. The reason why this is drawn flat, even though that we know that it's actually on an angle in real life, is because we only have 2 of the 3 dimensions that we can show. Remember, 2D. So as we're looking at this, if we go from left to right over here, this is actually the width of our shape. If we go up and down in this direction, this is the thickness or the depth, which means that going from this top portion down to here is actually part of the height. Well, on our top view of our multi-view drawing, there's only 2 dimensions that we can show, and that would be the depth going up and down here, and the width that is going left to right. So we can't actually show the slope just because that's a 3rd dimension that we can't fit. When we look at our side view, again, same thing again. We have this rectangle right over here. That would be this rectangle. And then we have this small little rectangular surface down at the bottom here, and that would be this right here. So again, kind of key points of this is, or main idea for this second key point, I should say, is that when you have your isometric, you want to make sure each of your views match whatever your isometric is. So those are the first 2. The third key point is to make sure that all of your edges and all of your features actually match up. So here's what I mean by that. If you look at this front view and then you compare it to the top view, you're going to see a few different things here. If you look at this outer edge, this edge lines up with this edge over here. It's not over to the side, it's not way over here. It matches up perfectly, just like that. You want to make sure you do that with all of your drawings. Reason for that is if we go from our front view, and this edge right over here is actually this edge, if we flip it and we go back to our top, we can see how these two edges actually match up with each other. This edge is over here, this edge is right there. So you want to make sure that they actually match up on here as well, because that's what they look like in real life. If we keep going and we compare the two, we can see that we have this edge right over here. This is actually matched up with a hidden line, these dashes, and we'll get into this in just a moment. We have this little corner over here, which matches this edge. And then again, we have this outside edge over here, which matches that. When we look at our side view, same concept. We've got the top of our front view that matches the top of our side view. We have this little corner right over here, which matches this edge. We have the bottom edge, which matches the bottom of the side view. And then we also have this surface right over here, which matches this hidden line. So that's the third key point. You want to make sure that all of your features match up. If something doesn't, let's say, for example, you forgot to draw this line over here, and yet you have something down here, that tells you that something's wrong. Same thing if, let's say, your top view ends way over here, and your front view is still over here, you knew you drew something wrong. So it's a great way to check your own work to make sure that everything is the way it's supposed to be. One last point to that too is if you were to take a measurement from right here and right here and compare that to this measurement, those should be the same as well. If this was 2 inches, this should also be 2 inches. So that's the other kind of feature to make sure that, because when we're looking at the thickness, right, if this is my thickness from the top view and I go to my side view, the thickness stays the same. It doesn't change. So again, the thickness or the depth should be the same between your two drawings. All right, now our final key point to remember when we do our multi-view drawings is that we want to use hidden lines when we need to. These solid lines that you see, these are all called object lines, and they show edges that you can actually see. If we look at our actual front view over here of our shape, we've got all these outside edges, and you can see all of them. So when we draw them, we want to make sure they're nice and solid. A hidden line shows an edge that you can't see, one that is hidden from that view. So from our front view, we can actually see the cutout over here. So you can see it here, so we draw it. When we look at our top though, our top view, all of a sudden we can't see this cutout anymore. It disappears. I actually drew a set of hidden lines on the shape itself so you can get an idea of what that's showing. But when we draw this, we use a set of dashed lines to show that there is an edge that's underneath the top surface. So hidden lines, they always show edges or surfaces that we can't see. Same thing when I go to my side view. If you look at the side view straight on, you can't see the cutout that's underneath over here, but we still have to show it. And so I drew a set of hidden lines right on the edge over, or on the surface over here. It's kind of hard to see, but again, if you get the idea, you can see how these hidden lines over here match up with that surface. So it's showing that there's a cutout just, that's there. There's an edge that's behind the solid surface. So those are the 4 key points to a multi-view drawing. Number 1, making sure your views are in the correct spot. Front view, bottom corner, top view above, right view or right side view over to the side. Second key point, making sure that if you have an isometric, your views match. So this front view on our isometric is the same as our front view on our multi-view drawing, same as the top and the side. Third key point, making sure that all of your edges and all of your features match up, right? If we look at our outside edges, they always match. Anytime we have a change in our shape, it should be shown on the adjacent view as well. So this little corner matches that edge. This little feature over here matches that hidden line, and the same thing over on the side. And then our last key point is to make sure we use hidden lines whenever we need to. So if there's an edge that's behind a solid surface, you always want to make sure you show a hidden line or add a hidden line to your drawing so that you can show that that's actually supposed to be there. So I hope that helps. That's multi-view drawing. That's the basics. Thanks for listening.